Hi. Okay, we're going to start with that worksheet that you just got today. It's Photosynthesis, Review, and Graphic Organizer. So if you haven't gotten that yet, pause me, get that handed out, and then right after this, we're going to use the notes that we started last week. So make sure you get those out also. So if you don't have those out already, push pause, get that going. Otherwise, here's where we're going to review. It was a long weekend. I hope you all enjoyed it. But we need to quickly review that. We were talking about photosynthesis, and we remember, hopefully, that in photosynthesis it's plants taking sunlight energy with water and carbon dioxide, turning that into glucose and oxygen. But we talked about how that happened in two parts, two phases. The dark reaction, or what we call the Calvin cycle, that was the second part. And then last week we learned about the light reactions, the first part. So let's just quickly review the chloroplast, because remember, we're only talking about plant cells. Only plants can do photosynthesis. Only organisms with chloroplasts can do photosynthesis. So we're going to take a look at the chloroplast, review what we learned last week, and then we're going to learn a little bit more about the Calvin cycle. Okay, so here is a picture of our chloroplast. And in your chloroplast, you're only required to label the thylakoid and the stroma. I showed you, just to make sure that you remember, chloroplast has two membranes. So does the mitochondria. They're two energy organelles or cell parts, and they both have two cell membranes. Eventually, we'll talk about why that is. Right now, just remember it. So we've got the inner and the outer membrane. Then once we get on the inside, it's just two parts. There's only two things going on inside a chloroplast. I know the words are not fun to remember, but there's only two parts. And it happens that there's only two phases. So, phase one takes place in the thylakoid. That's that disc. Remember, there's stacks of them. We call the stacks granum or grana. You don't have to memorize that. But just if you see it somewhere, I wanted that to be something that you saw. So if you see that word someplace else, you don't get confused and say, oh, Miss Cameron told us it was a thylakoid. This book says it's a granum. The difference is that a granum is a stack of thylakoids. So we're just focusing on the thylakoid. So the thylakoid here, and then everything in between these stacks, all that empty space filled with fluid, that's the stroma. So those are the only two parts that you have to know. So make sure you get your chloroplast labeled right now with the thylakoid and the stroma. Those you do have to know. Okay, then we also learned last week that photosynthesis happens in two parts. So I'm going to call them phases for right now. Phase one happens, we call that the light dependent reactions. These are dependent upon light. And since the thylakoid has chlorophyll, that's the stuff, that's that pigment that attracts the sunlight, that has to be where the light reactions take place. So we sometimes call them the light reactions or the light dependent reactions. The other part is the light independent. Spell reactions, sometimes called the Calvin cycle. Oh, and I knew that this wasn't going to. So somewhere put this in there. Maybe I can fit it in there. I'm probably trying too hard here. Anyway, make sure that you understand that the light-independent reactions are the Calvin cycle, and we're going to cover that a lot today. So make sure that that gets in here, right in here. Make sure you put that in there. That light-independent is also called the Calvin cycle. All right, now let's talk about where these things take place. The location. The light-dependent reactions, like I said, they take place in the thylakoid. Okay, that's those little discs. The light-independent reactions take place in the stroma. All the other stuff on the inside. So we only have two parts in the inside. One takes place in those discs called the thylakoid. They have the chlorophyll, so that has to be light-dependent. The other stuff takes place in the stroma. Okay, so what is the main purpose of the light-dependent reactions? The first part. We're going to harness the sun's energy. So we're going to create, you guys remember we make those energy molecules. We make those energy molecules ATP and NADPH. So we harness the sun's energy by breaking a water molecule, and we make two energy parts, ATP, NADPH. NADPH carries electrons. Remember me telling you that electrons have so much energy that they can actually be damaging? So we can't just let these high energy molecules float free. They have to be bound up or tied up in a chemical or a molecule to be transferred somewhere. Then they can be set free to use that energy. So we're going to harness the sun's energy, and then in the second part, we are going to use the energy to build glucose. It's going to be challenging this way. Here we go. Okay, so we're going to use all of those, that ATP and NADPH, we're going to use that to build glucose out of carbon dioxide. So what goes into the light-dependent reactions? Okay, so remember when we were looking at our picture from last week, in the thylakoid, we had the sunlight coming in and the water coming in. Okay, so those would be our inputs. We're using sunlight and water. And we break that water molecule into three parts: electrons, hydrogens, and oxygens. Oxygen is a waste product. The other two build energy molecules. Okay, so if that's our input, let's go right to our output. So we take sunlight and water, and like we said, we make oxygen, so that's going to be a waste product, so let's put that in. And it's going to be a waste. Then we also make two energy molecules. The hydrogens are used to make ATP, and the electrons then get harnessed in NADPH. Alright, so hopefully you have an easier time fitting that in there. Okay, so what we're going to learn today, though, is that we're going to take those energy molecules and we're going to make glucose. So obviously these two energy molecules that were once the products, now they become the reactants. We call that a pathway. When you take the products from one reaction and it starts the new reaction, that's a pathway. So this pathway, we start with ATP, NADPH, and then this is also where we take the carbon dioxide. So we take carbon dioxide and these two energy molecules, and I'm just going to put the 2 right there, and then we have really only one product in this one. Our product is then glucose, or sugars. Technically, we build smaller molecules that will be used to make glucose. But we're just going to say we build glucose. So let's just quickly go through this, and then we'll move on to the next, to talking about the Calvin cycle. So we've got 2 phases, light dependent and light independent, or the Calvin cycle. The light dependent happens in the thylakoid. Chlorophyll absorbs sunlight energy, and we turn that into oxygen, ATP, and NADPH. Now we go into the stroma for the Calvin cycle, and there we use those energy molecules to build glucose. So we take ATP, NADPH, and carbon dioxide, and we make glucose. Okay? So, stop here, pull out your other notes, and go to the next video where I talk about the Calvin cycle.